Hi, today I want to talk about a feature that you'll find extremely useful for troubleshooting and performance validation of your SQL Server instances. However, although it's been available since SQL Server 2016, it has been disabled all the way up until the latest version, which is SQL Server 2022, or in the PaaS equivalents in Azure, and that is Query Store. You may have already heard of it, you may be using it, but in order to use it prior to 2022, you do need to enable it yourselves. So it may well be a feature that you've never heard of before, never used, don't know how dangerous it is, what problems is it going to cause us. So we're going to walk through setting it up, looking at what we can do to actually capture information and analyze an instance. I'll also explain how it captures the information as it's running. So I've got a database instance. In fact, the instance I've got here is actually a managed instance. And normally the databases have Query Store enabled. But in this instance, if I look at Query Store within my properties, we can see that Query Store is currently turned off. So to turn it on, I can just change the operation mode to read write, and then it comes up with a set of default values. The flush interval, 15 minutes. The information that is stored in Query Store actually comes from your cache. So when you're querying the cache for query stats, SQL text, procedure cache information, that is what is being delivered to your Query Store. And the Query Store itself is sourced on your databases. So it is within your primary file group. What it does is it captures that information and it persists it into each of your user databases. So unlike when you're querying the cache, which you would do on an instance specific basis, for Query Store, it is done on the database level. So you have to enable it for the databases you want to enable it for, you want to performance tune, which can be all of your user databases on the instance itself. By default, the statistics collection interval is 1 hour, but you can change that anything from 1 minute to 1 day. What the collection interval is like a window of when all of your queries are running. So you can look for any particular hour of the day and find out what was going on in the space of that hour, what was run, how long it took, how much CPU it took, and so on. We can limit the number of plans per query. 200 is a default, which is quite a lot. The max size is a default of 100. Now, that is when we're using compatibility of 2016. But when we move on from there, it generally defaults to 1000 meg or 1 gigabyte. The query capture mode of auto means that it will capture anything that is not trivial. So anything that potentially is going to cause query issues on your server. If it is something trivial, then it won't capture it because it's not something that you can optimize. You can change that setting from auto to all, which means capture absolutely everything. Capture none if you don't want it to capture anything for the time being, or you can set a custom set of parameters, which are further down here. Other things to be aware of is the cleanup mode, which is set to automatic, which means it will start to clean up as and when it needs to do. In other words, your limit on size is starting to be reached, and also based on the stale query threshold days of 30, which means it will hold query information for 30 days as long as there is space available. Finally, there is a wait statistics capture mode. Now, unlike the DMOS wait stats, DMV, which it gives you granular level view of the different weight types, this is more weight categories. So for instance, all of your different lock types are all bundled into one lock category. Same with latches and same with other statistics as well. But it is still very useful for understanding what type of weights have been going on in your queries running on your databases. In 2016, this wasn't available. So from 2017 onwards, you now have the option of turning weight statistics capture mode on or off. And by default, once you're enabling Query Store, that will turn it on. Now, you have to enable this at a database level, which can be time consuming if there are a lot of databases on your instance. However, this query here will enable me to run this not only on all of my user databases to turn them on together, but it will also run it against the model database as well. And by running it against model, it means that any new databases that I provision will also come with Query Store enabled by default. So that's a quick look at what Query Store is. In terms of what sort of issues you may find with it, it's going to be writing data to your primary file group. So as long as your primary file group is away from other file groups within your database and the storage is provisioned adequately, you should generally find there is no problems at all with it. If you are using primary file group for everything, even so, Query Store is fairly lightweight, but just be aware that there can potentially be a little bit of blocking. However, unlike other performance tuning features we have, such as extended events, we do recommend that Query Store is enabled on a permanent basis rather than just turning it on as and when you need to do. If you have an availability group and you have readable secondaries, then you can offload the read of Query Store to your secondaries themselves. However, when we move to 2022, there is also an option of being able to use the readable copy of Query Store to analyze the readable replica itself rather than the primary. So there are multiple options coming through for Query Store. However, we're just going to go with the basic features for now, pretty much as of SQL Server 2017. And we're going to analyze this managed instance and just two databases in particular, Contoso Main 1 and Contoso Main 2. Now, I could go into these databases and you'll find there is a Query Store option in here with a set of reports ready available for you to run. However, rather than using these, I'm going to produce my own set of scripts and some Excel spreadsheets to be able to collect this information and analyze it. So here is the blog that I'm going to be using in order to generate my information and do my analysis. So if I take the link and go onto my server and then just open Edge, and now I'm going to download my code. Once that's downloaded, I'll go to my downloads folder and extract everything. And now I've got my scripts folder and my Excel templates. In my templates, I've got one for instance information and one for performance report, which we'll take a look at shortly. And then in my scripts, I've got some for collection and then others to do some analysis. So everything that I'm going to do for the time being is all related to Query Store itself, and I'm going to be using the scripts in the collection folder. So the first one I'm going to start with is Query Store Performance. And when I open this, I have the ability to now run it against each database that I want to capture my analysis results for. And I also have a window that I want to set for capturing. So in terms of this instance and the database, I've previously been running a bit of workload on both databases, and that was done yesterday. So I'm going to capture for that window, and that window is yesterday from 12 o'clock UTC time to 4 o'clock UTC time. So if I go to console main 1, first of all, and then execute, and that's going to capture everything that ran during the 4 hours against that database. To then insert the data for console main 2, I just need to select the scope of the second database and then just comment out this drop table and then run again. And that has now captured everything in a global table variable called query store perf. And now I'm going to do the same with my weight statistics. So first of all, console main 1. Make certain I don't drop the table, and then do the same for console main 2. Okay, now I'm ready to analyze the data. So first script I'm going to run is one called chart performance. I need to work out what time zone is best to get the local time for whatever setting my server is at or wherever I am based. So I need to run this query first to get the time zone information. And the time zone that I am in is this GM standard time. So if I go to current UTC offset of 0, and there is GMT standard time. So that is the one that I'm going to use, which is what I've got in my variable. I also need to provide how many cores are on this server or this managed instance in this case, and it's going to use that to try and calculate the CPU time. So this managed instance has got 4 vCores on it. So when I run the script now and then move to the second data set, this now captures information that will populate a chart for me in my spreadsheet. So the spreadsheet that I'm going to look at first is my performance report one, and I go to the performance data tab and paste the information in here. And you can see that for the 4 hour time interval that we're looking at, we've got 4 entries, 1 per hour for console main 1, and then again for console main 2. Each shows the start time in local time and the same in UTC time. Because I'm using Greenwich Standard Time, it is in this case the same. Then I've got my end time, which, because Query Store is set at 1 hour windows, it is now 12 till 1 o'clock, 1 till 2 o'clock, etc. If you change it to be every 5 minutes, you'll get a window for every 5 minutes of run. So 12 to 12:05, 12:05 to 12:10, so and so on. So as well as that, we get information about the execution times, the durations, the CPU minutes, reads from memory and disk, and even wait times at the end as well. Now that information is then presented visually. So if I go to performance charts and then into data and refresh all, and that will show us a graph of, first of all, CPU, showing that console main 1 has the higher CPU, just above 50%, and then when you add the console main 2 as well, it's roughly averaging around 90% of my CPU. So in terms of this managed instance, it is running very hot and almost at max capacity for CPU. As I scroll down, it also shows the number of logical reads, fairly high in terms of the number of terabytes. It's around the 12 to 13 terabytes per hour of reads from memory. However, in terms of physical reads, we're talking less than 6 gig per hour, hardly anything at all. And that is all in one database, console main 2. Console main 1 has not done any physical reads at all. And logical writes is very low as well. So we can see that in terms of what I want to analyze for performance on this instance, it all seems to be relating to a large amount of CPU and potentially logical reads as well. So now we're going to move to our next tab of duration. And what we want to do here, before we actually go to duration, let's go back to performance data. And at this point, once we've had a look at the chart, we may decide that there's a particular time of interest and a particular database that we're interested in. So for this one, for this report, I'm going to worry about database console sum main 1, and I'm just going to look at the runtime stats intervals 634 to 637, which is basically all 4 intervals used during this time. But what I could do is I could say, oh, let's just take these two, give it an highlight, let's highlight it in yellow, and then point out that these are the only 2 that we're going to analyze in the rest of the spreadsheet. However, in this case, we're just going to do all 4 and for console sum main 1. So now we're going to go to the duration tab. And if I go back to my instance and move to the duration report. And before I run this, I need to check a few variables. So first of all, what database am I going to be running this for? And it is console sum main 1 in this case. And then what window am I going to use? So 634 to 637, I've already got that set. If I just go back to performance data, these are the 4 windows that we are interested in. So everything is set ready for me to run. So if I execute this script, and this is not querying query store itself, it is querying the table variable that I created previously. So I can take the results and populate my spreadsheet. Now this part of the spreadsheet itself is ready to hold 50 records to pick up the top 50 worst performing queries. In this case, there aren't all that many, and in fact, there's only one query that we're actually interested in here, 75% just for this one query alone. However, just to carry on working with this, what we would do now is look to see how many queries are consuming 80% of the overall duration time. And in that case, it is 3, which come up to a total of 83.49. And once we've done that for duration, we just continue to do the same for the rest of the categories as well. So starting with CPU report, again, make certain that the database is correct, that the start and end time IDs are correct, and also for this one, that the number of cores is correct. And again, this managed instance does have 4 vCores. So we can execute that and we can continue to populate the spreadsheet. And again, for this one, 94% of the overall CPU, which as you can see for this database is averaging around 53%, just over that 50% mark, but the majority of it is this one query. So for 80%, it is just the one query. Then we move on to logical reads. And again, this one, we've got 25 terabytes of reads from memory through that 4-hour slot, that 4-hour window, and virtually all of it is by the same query. Now, I could continue to do the same for physical reads, logical reads, and weights. However, there's very little in terms of them. So I'm going to move on from here and skip to the next part, which is to look at the worst performing queries. So I'm only interested in looking at worst performance for duration, CPU, and logical reads. So I go back to duration and look for my worst performing. The only one I'm interested in at this point is query ID 77. For CPU, it's still 77, and for logical reads, it's also 77. So for the worst performing query, I'll just take a copy of the database and the ID. And for the overall, just 77. So now I have that information. I've actually got another query here that I need to run, this time against Query Store, and that is to get the actual SQL text that I need to investigate. And underneath, I want to investigate the execution plan as well. So I now run another report, and this one is worst queries by plan ID. So again, for this one, console main 1, make certain my window is correct, and then I need to list out a comma separated list of my query IDs in here. In this case, it's only one query, and that query ID is 77. So I can now execute this. And again, this is just looking at the query store performance and the query store weights table variables. And it returns 2 bits of information. The first one I copy and go back to my spreadsheet and I paste in here so that I can now get the plan from Query Store itself. And then the second bit of information I put into my final tab, which is worst queries by plan ID. Once I've done that, I go back to worst performing queries and I can now grab my queries from here and just open up a new window so that I can run both of these. So there's the first query. If I go back to my spreadsheet and now grab this one. And these two are running against Query Store because at the moment I've captured all the statistics, but I haven't actually captured the SQL text for the query or the execution plan. So now I run to capture them. And I can just paste this one into my window. And we can see it looks a fairly straightforward query. And that is against console main 1. And then we also want to have a look at the query plan. And when we look at the query plan, we can see there's a clustered index scan. It's using parallelism, and we've got a warning triangle. The triangle showing that we've got an implicit conversion on ship ID compared to the parameter. So if we have a look at the query again, and we can see the parameter is an nvarchar 4000. If we have a look at the table we're querying, the ship ID is a varchar 10. So that means it's doing an implicit conversion of ship ID for every record in the table. So we'll just have a look to see how many records there are in this table. And I'm going to query sys.partitions rather than actually do a count of the table itself. So if I do select star from sys.partitions for this particular object, and that tells us that there are 4 million records in the table. So the problem with this query is it's implicitly converting not the parameter, but actually the ship ID column, because it is a varchar. And when working with an implicit conversion, it must convert where it fits. And converting an nvarchar to a varchar, it might fit, but it might not. An nvarchar is 2 bytes. A varchar is 1 byte. So if it's an ASCII character in an nvarchar, it should be okay to downgrade it to a varchar. But if it's non-ASCII and it's something that needs 2 bytes to represent it, then that would throw an error if we tried to convert it back to being a varchar of 1 byte. So that is why, unless we explicitly tell it to become a varchar, it will automatically change varchars to nvarchars, not the other way around. So in order to fix in the application, we can make the parameter a varchar. It's not always easy. Some applications, the application code converts straight away into nvarchar, so it's not as easy as you think, but that would be the ideal solution. Sometimes you may end up having to change the table, and that's the worst case scenario, where we actually have to change the column from a varchar to an nvarchar, which makes the table bigger and can take a lot longer to do and cause problems with the log if we're not careful. If the query is within a stored procedure, it's very easy to resolve because we can start with the nvarchar and then we can just put a cast on our varchar here. So there are several ways around it. So if we take an example, and one way of being able to get an example is to go to the execution plan. So within here, if I right click it and show execution plan XML, and then scroll down to the bottom, and here is my parameter, and the value that was used to compile this plan was A. So if I specify that as my value and then execute this, it takes around 5 seconds to execute and actually doesn't return any data at all. If I change the parameter from an nvarchar to a varchar and run the same, it comes back in sub-second. If I put that back to nvarchar and then cast, then again, it comes back sub-second. So that's shown how to look at a performance issue using Query Store to get to the bottom of what is causing problems on our instance and to actually then look at the issue and potentially, hopefully, to fix it. To help troubleshoot along with Query Store, there are some other scripts that I've added to my collection folder. So if I go back into collection, we've got CPU, information about database files and object size, index information, some other queries, and statistics information as well. So just to start with CPU. Now, there's nothing going on as such on the instance at the moment, but if I run this, it will give me the CPU information by the minute for the last few hours, including what the SQL CPU is, the idle time, and any other CPU that may be going on. So we can take a copy of this and put it in our other spreadsheet in the CPU tab. Next, we have DB files. And this is one that we can run against each database. So if I start with console main 1 and then execute, and this gives me all of my databases and file information, including the physical name of where it is and the logical name for it, the size of the files, how much space is used in them, what type of file growth is being used and the max size, and then also IOPS information, such as the IOPS, the throughput, and also the read and write latency. So everything is done at the read and write level for these files. So you can use this information to find out how your database is growing, and also what latency you're having and what your IOPS are currently for your files within the database. So if we take that information, I can then populate the file info tab. Next is object size. And with this, again, you run it on each database that you want to run it on and capture the information, and we can put this in our object info. And this captures information at the table, index, partition, and allocation unit categories. So we hold information here that tells us how many rows there are in each table, and per allocation, per partition, and also the size of them as well. And then with this detailed information, we can then go to object summary and do a data refresh to get information table by table. What we should generally find is if we look at the total size, it should roughly be the same as the file information. So 20,000 megabytes in total size. In the file information, if we go to space used, it is near enough 20,000, and that is roughly what it will be equivalent of. So we can now break down the actual space used in a database file or database files and compare that to the objects that we have within our database. Next, we move on to index info. And for this one, you run it against your database, but you run it for a particular table, a table that you may be having problems with. You've looked at the query and finding that one or two tables in the query seem to be the reason behind your performance issue. So you want to get more information about it. So in this case, I'm just going to use human resources schema and the employee table. When I run this, it gives me information about the index itself, just metadata information. So if I go into index info, I can now populate, and it tells me what the index keys are and what the included columns are. Other information such as does it have a filter and fill factor and so on. Next, I get index usage, which is the second data set. There isn't anything here, but if your index has been recorded as being used recently, then you'll be able to see it in here. If they're not being recorded as being used, it may be a case that you can delete the index, drop the index because it's not being used. So something that will give you a good indication of how well your indexes are being utilized, how often they're being scanned, how often they're being searched, and how often they're being updated as a comparison. And then finally, there is index operational stats. And this gives information such as how many inserts you are getting, updates, singleton lookups, how many scans you're getting, even looking at page and row lock information and page I/O and page latches. So how much latching is going on in memory and how much latching is going on at the disk level. Next, we move on to other queries. And these are two queries that work at the instance level. So the first one is system information. So we go all the way back to the left and we can put this information in to find out things like how many CPUs we've got, which memory is being used, how much has been committed and how much is visible to your SQL instance, and also how many worker threads you've got working on the SQL instance, and when was the last time your instance was restarted. We also get memory information that we populate into the memory tab, and this will show us which memory clerk is consuming the most memory for our instance. Finally, we move to the statistics info. And again, if I do this at the human resources and employee level and run again, this will give me metadata about the statistics and also the histograms available as well. So if I go all the way to the end and into statistics info tab, and this tells us information about each statistic for a particular table, when it was last updated, have there been a lot of modifications to it, and what columns it represents. And then we can take the histogram information and potentially use this information to look at the compilation of certain execution plans, looking at the parameter that was provided as part of the compilation of the plan, and try and understand and gauge what the optimizer is trying to do in terms of how many records it thinks it's going to pick up for that table and for that particular parameter. We can use this to work out whether our statistics have been updated or if they're being updated frequently enough, and also whether there is a parameter sniffing issue in our query. So hopefully these will help you in order to be able to tune your database instance.